My name is Ava Fuller.
And my name is Nora Pruzan. And our project is about the demographic and clinical characteristics among people diagnosed with schizophrenia and those with co-occurring substance.
So I thought it would be important to first recognize how we got interested in this project. I started in sophomore year, and I first got into psychology because I found it really interesting how ambiguous and difficult it was to physically measure. It's almost like another world that we have yet to be able to understand. So I also thought it was an important topic in the current world because of its rising numbers of individuals affected. For schizophrenia specifically, I found it to be an interesting disorder in itself, and I found how I was captivated by how uniquely it affected individuals, especially with the delusions and hallucinations that are associated. And it feels almost unlike any other the commonly found neurological disorders. I wanted to begin to understand how these mechanisms work and question how it was possible that people's own minds can be convinced and trick them into thinking that they actually see or believe such things, especially so vividly. So that's kind of why I was interested in schizophrenia.
And then my psychology motivation kind of stemmed from the fact that a lot of my family works in psych. Like my mom was a clinical social worker. So I've been learning about psychology from a young age, and I was always fascinated by how many unknowns, especially in psychological disorders. And I questioned why that was and why, even with all the research done, there are still so many more unknowns surrounding the human mind and body. And then for schizophrenia specifically, I found it interesting that it's very uncommon, but it is pretty commonly researched. And there are just so many unknowns, such as underlying causes and just a plethora of symptoms. And so much could be researched and discovered, and that really excited me. And we wanted to learn more about how it affected people's lives, as so much less is known about it in comparison to other disorders such as depression or anxiety, which are two of the most common psychological disorders are diagnosed with. And actually, this is kind of shown in our data set because depression was the most represented psych.
Okay. So first, we're going to start with our background information onto our project. Schizophrenia is a condition that heavily affects the way an individual may think, feel, or act. And the observed etiology includes a makeup of genetic, environmental, or other neurological factors, but again, it's still not really researched enough. Current available treatments for schizophrenia can include a combination of antipsychotics, cognitive behavioral therapy, and other general therapies that can increase their ability to live a normal functioning life. Across patients with schizophrenia, many of the common symptoms include delusions, hallucinations, disorganized speech, aggression, and social issues, but that's not an exhaustive list. And then substance use disorder relates to the persistent use of drugs that leads to significant dangers, including self and or others. The most common substances that become abused is alcohol, followed by cannabis, prescription medications, meth, and opioids. Problems related to substance use disorder can often interfere with daily and normal activities, including work. Substance use disorder, like schizophrenia, can be triggered by genetic vulnerability, but can also become caused by environmental psychiatric. Schizophrenia and substance use disorder can commonly become co-occurring and work together. Schizophrenia, those with schizophrenia generally have a higher likelihood or become more susceptible to developing a type of substance use disorder than compared to those who do not have any type of mental disorder. But mental disorders in general are related to higher rates of substance use disorders. And then prolonged substance use is also observed to have a worsening. Through our project, we were interested in exploring the differences in life quality among patients with schizophrenia and substance use disorder versus individuals with schizophrenia. And we thought it was important to be able to understand how these populations differ from one another, if at all. And from there, we may be able to more closely recognize how the disorders are related and where they diverge from each other. We think this can lead to an overall greater comprehension of the two conditions and how they work together to affect one's life.
So our project uses the Substance Abuse and Mental Health Services, or SANSO, which is how it's shown in the annual mental health and client level data set. And this is a publicly available data set that collects information from patients who receive publicly funded mental health services in the United States. And so the data set originally included millions of patients, and that number is exactly 6,957,919 patients. So it was far too large to work with. And we used a data analysis program to filter the data set so it only schizophrenia as well as substance use disorder. However, that number is still quite large as it is over 700,000 patients. And we use substance use disorder rather than substance use problem. And we examine demographic and clinical characteristics, so education level, employment status, and site of care of patients diagnosed with schizophrenia. And that number is exactly 741,000. And so then we compared patients with substance use problems to those without, so patients diagnosed with only schizophrenia, and used a regression analysis to further interpret the correlation outcomes of the variables, and the effect sizes are shown in the.
That's very smart. And then for study results, we found that patients were middle-aged on average. 62% were male and 52% were white. A majority of them never married and were not in the labor force. And we also found that over 90% did receive care in a community-based program. For all schizophrenia, 46.7 had a substance use problem. And the effect sizes for the relationship between substance use disorder and age, race, ethnicity, employment, and treatment were rather small. To be specific, it ranged from effect sizes of 0.1 to 0.2. For the differences that we found, schizophrenia and substance use disorder patients were more likely to be younger and unemployed, which is in the chart. And then they were also seen to be more likely to have received inpatient services. In addition, we found that Asian and white individuals were underrepresented in the comorbid group, while African American and Puerto Rican individuals were overrepresented, which is shown in the pie graph. So the results of our experiment show that basically co-occurring schizophrenia and substance disorder is associated with high risk of employment and inpatient treatment, which, like Ava said, 90% of those in the study received care. And although America's health system may strive for equity and equality, we are far from where it should be. And again, this is shown by the fact that the study shows that there are higher rates of substance use disorders in patients and some Hispanic patients. So again, this could reflect systematic biases in diagnosis or other social determinants of health that disproportionately affect these two communities. And again, these are shown in the pie charts. So going back to figure 1, the effect sizes from the residual test were all very small. So there are many confounding variables that contribute to people's substance use when also diagnosed.
Are there any questions? If you have questions, we want to come up to the microphone. So
just a real quick one. You said that the schizophrenics are substance abusing. What substances are they abusing?
We found that it was mostly alcohol. That was the most common. And then I think the other was second.
All right, thank you.
nice job, ladies. So folks, here we've got a classic case of what in anthropology we call intersectionality, where you have basically the whole is worse than the parts because they interact. So you've got the well-known correlation between unemployment and depression and substance abuse, and probably an underlying strata of structural racism that goes, which it makes these things so hard to understand. But did you have any ideas, and it's fine if you didn't, what might be the best way to start addressing some of these issues? Or is that beyond the scope of what you would?
So we didn't exactly get to that point, but we're definitely going to more research on it with our because that is the thing doing.
Big answer for next semester.
Thank you.
What do you think is for the gap in those not in the labor force between those with only schizophrenia and those with schizophrenia and substance use disorder?
So we didn't exactly research that, but that is something that we should. Yeah.
You said that your data set was from those you receiving unfunded care. How do you think that may have affected your results using from the bias in that population? Again, the overall population.
I mean, I guess it does depend on who has more access to these resources. So it's probably a lot more people that do have those resources. So it's probably not fully representative of the entire population.
In what direction based on the metrics that you are using?
Of like unemployment.
For the for your results with population demographics, what direction do you think the data set pushed that?
That because we got government assistance, it skewed what data was provided. So, just trying to boil it down, how has what the government has deemed as the standard for schizophrenia potentially shifted the data set? And for you to have some sort of, I guess, omnipotent view of this, what you think would shift towards? I can answer right? It makes sense.
So there are a lot of biases like with that. And we kind of talked a bit about how like in the results. Like there are a lot of systematic biases in the results. So
All right, hi, I'm Henry.
I'm Naomi, and our project is studying black hole disruption events from two data sets opposite lines.
Okay, so a tidal disruption event occurs when a star gets too close to a black hole and the force of gravity from the black hole ends up ripping the star apart, and half the star then falls onto the black hole, which forms an accretion disk and lets out a very bright outburst of light which we can detect with our telescope. And then so this occurs because as the star gets closer to the black hole, the gravity on one half of the star that is close to the black hole is so much greater than the gravity on the other half of the star that it overcomes the internal gravity of the star and ends up ripping the star apart into two.
Specifically, since the black hole is rotating around its center at an extremely high rate, and the star is not going to be orbiting at the same angular velocity, the star is accreted in a inward spiraling motion. This pattern. This results in a observed to the -5/3 power law decay of the luminosity both in X-ray and optical. So this pattern can be used to identify tidal disruption events from observatory data, such as that from this Swift X-ray telescope or these facility, which are an X-ray and optical observatory where we from. Our primary data set for the study was from the most recent catalog from these Swift X-rays or the second Swift point source survey. which measures X-ray detections and gamma ray bursts from 0.3 to 10 electron volt range.
All right, so our first candidate tidal disruption event is this first graph on the left. That's a graph of the light curve, which is the brightness versus time. And as you can see, this has a very clean looking light curve. It very closely follows the expected t to the negative 5/3 decline. So this is, so follows the clean decline. However, its brightness is not as bright as you'd expect from a tidal disruption event. And it's actually from the Andromeda galaxy, which is a nearby galaxy, and it's not from the exact center, which is what you'd expect, because usually it's the central supermassive black holes that are actually causing the tidal disruption events.
So our initial data set was composed of roughly 150,000 transient events. We narrowed these down by first matching with optical data, and then cutting out anything indicative that would be a stellar object rather than a black hole, such as or well, it would be galactic, also probably not a massive supermassive black hole. So, for example, parallax, if it is a TSS source, as well as the decay period, and as well as the overall decay period. With the remaining sources, we then ran them through a light curve that is what produced these two graphs that plot that fit all the data to the expected to the negative 5/3 power law decline. And individually analyze those light curves for effective characteristics, such as predominant green blocking over red, as well as to exclude sources that have to cut due to random variability in the light curve, or because if they were another event that has a similar decay pattern, such as a supernova. So one thing we did that isn't exactly standard procedure for this kind of survey is including AGNs, active galactic nuclei, which are typically excluded from searching for disruption events because the high quantity of X-ray emissions and their general brightness makes it more difficult to identify whether a source is actually a disruption event or just a blazar. So one of our
All right, so now our next candidate is the one on the right. And as you can see, the light curve is much messier with a lot more air and variability. And that's because this is a known AGN, which is a supermassive black hole that's already accreting gas. So it's already bright before the tidal disruption if it happens. But then, so which is why they're normally not looked at. But as you can see, it does have this peak, and it does have all the other characteristics you'd expect of a tidal disruption event. So we believe that this is also could be AGN tidal disruption event, and its brightness does actually fall right within the range of brightnesses you would expect from an actual tidal disruption event. So that would be an interesting find. And then, so going back to the first one, this is concluding now. So going back to the first one, this is, as I said, it's not from the center of the Andromeda galaxy. However, since it does follow such a clean decline, we think that it's still a black hole, and it's also an ultraluminous X-ray source, which is an object that astronomers see, but they don't exactly know what they are, which makes it an interesting discovery whether or not it is a TDE. And then, so what they think it could be is an intermediate mass black hole, which currently astronomers don't know much about at all. There's like very few discovered. So that would be a very interesting discovery that would, and since it's so close, it would help us learn a lot more about how these types of black holes could form and like why are they so rare. And then the other one, again, as we said, normally AGNs are removed when looking for TDEs just because they're so variable. But if we could show that it is a TDE and that this method is a valid way to find them, that would be an important step and let astronomers like find much more TDEs than they're currently just looking for.
Questions? Anyone?
I apologize, I arrived a little bit late. Could you just
Oh,
give me the 25-cent version between the two graphs?
Okay, so this is our, as you can see, its light curve is very clean. This is brightness versus time, and it has a very clean light curve, which makes it promising. It's either it's a star that's being ripped apart and falling onto something. We don't know whether or not it's falling onto a black hole or a neutron star, or if the star is being completely ripped apart, but we know it's one of those things. We assume it's not being totally ripped apart because the brightness of this, I mean, you can't tell because it's not scaled, but the brightness is lower than what you'd expect of a tidal disruption event. So that's the first one. This second one is just it's from a current like supermassive black hole at the center of a galaxy. And this black hole is already active before we detected this little like peak in emission. And that peak actually corresponds with the peak that you'd expect of a tidal disruption event. And so that is probably more promising to be a TDE itself. But yeah, both of these can follow the T to the negative 5/3 decline we'd expect. It's just they're different objects.
Thank you.
Are any of these observable by the James Webb Telescope?
I think they would be, but the James Webb Telescope doesn't really focus on such. I don't think it really focuses on such a close object as Earth because we already have telescopes that are not nearly as powerful that are just like one of our telescopes for data is in California. The other one's just a small telescope orbiting in space, and they can both observe it already.
You don't have to go directly with certain things.
Well, it depends what you mean by directly. Like, it's not going to show you an exact picture of what the object is, but it perceives the text from it, and it gives you a bunch of information about it.
Specifically, how the X-ray observatory data from works is it detects gamma ray bursts and then swivels to take measurements and photographic image of the area of the sky where it detected that gamma ray burst. So it is not specifically looking for or at specific objects. It's looking for specific.
In that viscous form, what would be the difference between an accretion disk when you have supernova and accretion of the focus as opposed to what is this?
So yeah, so for a supernova, you would just expect a very bright outburst as a star is exploding. And that tends to follow a power law decline, but not this same negative 5/3 power law decline. Or it does, but not so. Supernova tends to be much steeper because it's just so much less like mass that's happening. While this, what's happening is the star gets ripped apart. Half the star gets like just completely leaves orbit, while the other half gets flung out and then slowly falls as it orbits back onto the black hole, which is why you probably can't see the time here, but this is over the scale of hundreds of days. That's over the scale of thousands of days, while a supernova would be like a few weeks.
Just to be clear, accretion refers to the process of matter being pulled into a black hole. So a supernova would not have an accretion disk, even if it has similar emission patterns.
So hi everyone, I'm Catherine Valentine. I'm a senior at Columbia High School. And today I'm going to be talking to you guys about my work with the NASA Pandora mission, which is a satellite that is going to be studying exoplanets. Oh, no. Okay, so what are exoplanets? An exoplanet is just any planet outside of our solar system, but why do we study them? So your first thought is probably the search for life, which yes, we really want to figure out, are humans alone in our universe? However, studying exoplanets tells us a lot about our planet and our solar system. So, for example, we can figure out what makes Earth uniquely habitable. That the universe is actually abundant in water, but liquid water is what's very rare and what makes Earth very cheap. We can also study exoplanets to figure out different planetary and stellar systems, their evolution and their formation, and then compare that to our solar system to better figure out how our solar system. Okay, so how do we actually find exoplanets? So one of the main methods that we use to find exoplanets is the transit method. And the transit method is when we study the light of a star to look when there's a dip in the light, and that dip, so you can see when it goes in front of the dip in the light. And this tells us that an exoplanet has transited in front of the star. And then the size of that dip can tell us how large or how small the exoplanet is, how much light it's blocking. And also there's things like if there's multiple dips, it suggests that there's multiple exoplanets transiting that host star. And then we also can study their atmospheres through transit spectroscopy. So if you see the bottom video, transit spectroscopy is very similar, that we're studying the light of a star. However, this time we're looking at starlight that passes through the atmosphere of a planet. And this can tell us the atmospheric composition of it. So different elements equate to different light waves. So by looking at the wavelengths through the planet's atmosphere, we can figure out what elements are part of the atmosphere. We can figure out different things like, is there water vapor, is there hydrogen in there, and all these different atmospheric capabilities. So next, how does the Pandora mission? Yeah, so how does the Pandora mission actually tie into exoplanet studies? So I mentioned before that it's a small satellite and it is planned to launch fall of this year. And we are going to be studying the atmosphere of exoplanets simultaneously using visible photometry and near infrared spectroscopy with the goal of separating stellar and planetary signals. So Pandora, we're going to be observing a minimum of 20 exoplanet host stars, as well as over 200 transiting exoplanets. And the goal is to minimize the impact of stellar contamination. So stellar contamination is the interference from the variation of a star. So when you look at a star, it's not a uniform light source. It's going to have star spots on it, it's going to have flares, and it can just alternate in light brightness. So this can alter a planet's atmospheric signals when we're studying it. So this small sat is going to be used to study exoplanets from about the size of Earth all the way up to the size of Jupiter. But all these stars, all these exoplanets are going to be orbiting small, cool stars. And this is because it's going to make the atmospheres easier to spot as they're cooler and they're smaller. So it's going to be easier to look through the atmosphere. But these stars also are more active. So we're going to have more interference to be able to test the equipment. Yes. Okay, next. So what am I specifically doing with the Pandora mission? So I have been studying the exoplanet K2141b. So K2141b is an ultra short period or USP planet, and this just means that it has a period of less than 1 day, and a period is just how long it takes to orbit around its star once. So in comparison, the Earth, our orbit is 365 days a year. So to just put that in perspective, someone who was born in 2000 who lives on K2141b would be 32,700 years old. And it is a rocky, hot super Earth, and it is considered to be a lava planet as it has a surface temperature of over 2,000 Kelvin, which is approximately 3,140 degrees Fahrenheit. And to put that in perspective, the Earth's surface temperature is 59 degrees Fahrenheit. So, these lava planets are hot enough on its day side that they're able to vaporize and melt all the rock material on it, and this creates a magma or a lava ocean. And since it's heated above from the host stars, scientists believe these oceans to be stable on the planets. So we believe that K2141b once had an atmosphere similar to Earth's. However, it was lost due to its very close proximity to its host K2141. And this loss is due to the intense ultraviolet and extreme ultraviolet radiation from its host star. And it causes all the molecules to gain so much energy that they basically escape the planet's gravity and float off into space. This is called atmospheric escape, and it mainly affects planets. It affects them greater the closer you are to your host star. And you can kind of think about this very similar to Mercury, how it doesn't have an atmosphere like Earth or even Venus because it's so close. The particles in the atmosphere are not able to stay stable. That's exciting. Thank you.
There we go.
Okay, so how am I studying K2141b? So I'm interested in looking at K2141b's albedo. So albedo is just the ratio of light that the surface reflects compared to the total incoming sunlight, or in simpler terms, it's just how much light the planet absorbs instead of reflecting back to space. So a planet with a high albedo is going to reflect more sunlight than a planet with low albedo. So you can see at there in the top left corner, it's really high albedo because it's so bright and it's reflecting so much. Bottom right hand corner, you can't even see it. There's an asteroid in that picture. It's just extremely low albedo, but it's absorbing so much light that you can see it. So the planets with a high albedo are going to be cooler because they're not absorbing as much. And a planet with low albedo is going to be absorbing so much that's going to be much, much warmer. So the majority of planets we find do have low albedos because their atmosphere absorbs so much of the light, and because their surfaces are dark and rough. The exceptions tend to be frozen ice worlds, or planets like Venus that have a reflective cloud layer that are able to reflect back out that light. And then also it is referred to as the planet's like reflectivity. Next slide. Thank you. So how do we study albedo? If you could play the video. So we do this through a phase curve analysis. So a phase curve analysis is when we study the brightness of an exoplanet and how it changes in front of that, as it orbits in front of the star, and the portion visible to us, the phase shifts. So this analysis allows us to search within the planet's atmospheric composition, and we look for the potential of clouds mainly, which significantly impact the reflectivity of that star. So we base our study off of the Schoene study done in 2022. And in this study, they actually measured the albedo of K2141b, and they used data from 2 different satellites that study exoplanets. They used K2 and Spitzer. And with this, they collected 65 hours of continuous photometric observations over the course of 10 full orbits of K2141b. And for this, they used the Spitzer infrared array camera. And then they combined that data with the photometry collected by Kepler. And this was taken during 2 separate campaign missions. And then that is what Pandora is going to be following up on. And Pandora is so important for this because of the specific instrumentation studies. So in that Schoene study, the telescope looked at K2141b at both different times and in different light wavelengths. And this really gives us it's not a completely accurate image of the planet. Especially this is important for USP planets because since they're so hot, they also emit their own light. They don't only reflect back out the light from their star. So we must observe them in multiple wavelengths. So for the phase curve analysis done by Pandora, we're going to be studying it in visible and infrared light, and we're using their visible photometry channels and its near infrared spectroscopy channels. This is done by the visible detector assembly and the near infrared detectors. Next slide, thank you. So what are the actual implications of these studies? Why are we continuing it? So in the Schoene study, their team actually found a much higher albedo than we would expect from, so we base our study on the ESAC study from 2022. And in this study, they hypothesize that planets that have a lava ocean or quenched glass, which is just the glassy substance that's formed when lava cools really, really quickly, that these are going to have low albedos. So we would hypothesize that K2141b is going to have a low albedo. However, in Schoone's study, they discovered a much higher albedo than ESAC found in 2020. So if this result is accurate, it suggests really unusual conditions on K2141b, and this could be things like reflective clouds, mineral haze, or just a completely unexpected atmospheric composition. And these conditions are not only like crazy for K2141b, but for USP planets in general, because as we said, they're really hot. So they normally cannot sustain a reflective surface or even a reflective atmosphere. because we would expect all the planet's surface materials to vaporize. And even if these clouds were able to form on these planets, they should likely they would not be able to survive the radiation because they're so close to their star. So if K2-141b does actually have a high albedo, it will completely change the way that we study USP planets. So to recap, based on the literature, we think that K2-141b would have a low albedo. However, we have seen otherwise, and that's why we're continuing to study this planet, because there are those two antithetical answers from the different studies. However, the ZA study may not be 100% accurate, and K2-141b may not have such a unique atmospheric composition, because as we said, it was measured with two different telescopes in different light waves and at different times. So in the same way that, like, if you look at a painting in like different lighting at different times of day, it's going to completely change the nuances of it. The same thing is for exoplanet. So it doesn't give us a complete image of the actual planet. So this high albedo may just be due to the limitations of that instrumentation, and that's where the last slide. Thank you. Okay, so with these potential instrumentation issues, Pandora is really crucial in figuring this out because we're observing it simultaneously in both visible and infrared light, and it's going to provide a much clearer image of this planet. So I have been working with the Pandora science team, and we are currently selecting the top 20 targets for the satellite to study. And actually yesterday, K2-141b was selected as a primary target for Pandora. So while sadly I cannot give you a definite answer today, I am continuing my studies in the fall when the satellite launches. And that concludes the overview of my studies. Thank you so much for listening, and let me know if you
Have questions?
I have a question. You mentioned one planet had a very low albedo, and it just looked like a black square. How do you find those?
Similar thing with transiting, that we don't actually see those objects, but we see when they transit in front of their star, we see that that's a block of light. So we know that they're there, even though they're absorbing all the light.
How do you track them once you've found them? If there's no, I mean, it's moved away from the star. Does it just disappear as it moves around?
In its orbit, we can continue track. Any other questions?
For those types of objects, how do you know that it's not just like a sunspot?
Well, that's what we're doing with Pandora because it messes up the signals. So with those, we continuously track because star spots are not going to be constant. So if the results we're getting are constant, we can assume that it's probably a star spot. So those are going to be variable.
Does K2 like a nickname?
No, that's its main name. Yeah, there's also K2-141c.
They get their like their name.
Well, most exoplanets don't get like a name like Earth because they're just named after like the telescope that discovered them, and there's so many of them that we can't like give them all a name.
Is there like a 140? Is there like a 140A and a 140?
No, there's just a B and a C.
Do you have any current hypotheses for what might be causing K2-141b's higher than expected observed albedo?
I mean, honestly, all the paper and all the literature I've read, I really do believe that it's going to have a low albedo when we study it with Pandora. So I do think it's just the instrumentation and that there were so many different variables in it that were not canceled. That's causing that result.
If other than instrumentation, are there any hypotheses that you have? Or?
Yeah, I mean, well, the main thing would be that it's just going to have a completely unexpected atmosphere, and we would assume that it's going to have a reflective cloud layer like Venus. It doesn't seem too plausible because it is so close to the star, but I think the most likely answer for having that albedo would be because it has a reflective cloud layer that's able to reflect so much light. It would have to be really thick.
Sadly, so we cannot be here with us today. Actually, all of this was last time at the library, yes. But in my past life, and to some extent still, I'm a physical anthropologist. So when I saw this presentation, I'm like, okay, I'm not sure exactly what Zoe would have said to go with her PowerPoint, but I figured I could wing it because it's a subject I know. And I'm guessing that the first thing she would have done would be to put this context. Why do we care? Who cares how fast it is decompose? Ideas? Wants to know.
That in a case that.
Forensic scientists, crime scene investigators, forensic anthropologists, evolutionary biologists, where, for whatever reason, time or year or even century of death is important, and the factors that would influence that. I'm guessing some of you have all seen like CSI and Cold Case and Bones and shows like that, maybe. By the way, if you like Bones, go read the books. They're way. So the idea being that you have human remains, or in biological anthropology, they may be other animal remains, and you want to know, like in cases of forensic anthropology or crime scene, you know, when was this person buried? When were they deceased? Which helps you to find suspects, solve murders. In the broader scale, in terms of human evolution, it helps to know how much time has passed since someone was buried. And one of the limitations that we have in human evolution is, of course, burial and preservation to begin with, but also some of the effects that Zoe talks about. Where is her bounce? Okay. So one of the things, oh, why is this not advancing? It's odd. No, I'm advancing it here and it's not advancing on the screen. I don't know why. Maybe you should do it from there, because for some reason it's not advancing on the screen.
I'm happy to give it a shot.
Wait a minute, it just did.
It did. It's just,
It did. So, talking about aridity, there's a degree of dryness. Now we'll say hello to Tom Marlowe. Well, while we try to get this back up, let me try sharing again.
got it. Yeah.
Why this is not. All right, there we go. You got it. Okay. So aridity doesn't help dry. So there's four major groups, because of course how dry it is. It's not rainful. Like you all know that New Jersey is still in drought. So we've got everything running from, you know, desert, alpine, tundra are all considered arid environments. And any of you who've studied human evolution at all will know that most human fossils are found in dry environments, because decay takes longer, decomposition takes longer, and preservation is better. So if you look at the map over here, you know, this is where African Rift Valley, hotbed human fossil remains, and it's partly because this aridity factor. Okay, let me see if it will advance this. Yes, there we go. So this is the lovely thing to have over breakfast. And everyone had the breakfast. These talk about stages of decay. So of course, you know, you go into the ground, it's a nice fresh corpse. Again, not to be gross, but then because when decomposition begins, all wonderful bacteria that we carry around in our guts with us immediately start getting very, very active, and there's no active blood supply, give off gases, and when we get gases within our system, we all know what happens, right? Everything blocks up, which is why if any of you want to become a forensic anthropologist, you need to have strong stomachs. The next stage is the breaking down of the tissues, because without an active blood supply, everything stagnates, bacteria take over, begins to decay. We then get our advanced decay, which Kathy Reichs, who writes the Bones, actually refers to as stoop. That's kind of what it looks like. Once you get past that stage, everything begins to dry out. And that's where, you know, in the early stages of burial, your forensic anthropologist or your other crime scene analyst would come in and determine, based on the degree of humidity versus aridity, where the remains were found, be able to track back through these various stages and say, oh, probably not like in CSI where they say May 27th at 9:43 a.m., but would be able to give at least kind of a window which you could then use alibis, check whereabouts, and so on and so forth. So it's really fascinating stuff. And so Zoe breaks down, doing it again. Well, she talks about the environmental factors that are associated with this. I don't have to ask you to do it from there again. It is not advancing for some. Anyway, so oh, there we go. The major factors here are, as I mentioned, if you've got extreme aridity, you may even get mummification. It's one of the ways the Egyptians did mummification by taking everything out of the body and extreme dryness. Alluvial point of view, you know, all your little insects that eat things, the altitude and oxygen levels, and UV radiation also have a factor. And of course, the big one is our friends, scavengers. Range everything from, you know, you think out in the Serengeti, big lions pulling remains around. As an anthropologist, I can say there's been a lot of assemblages that look as if they are human made that are actually the remains of scavenger activity. Scavengers also come down to, you know, fish in the ocean, little beetles and things in our environments. So there's a lot going on there. In fact, what insect scavengers and larvae are present also great clues to what's going on. Oh, you're the best. So affecting the stages of decay. I said, I'm not quite sure what's going on here, so I'm kind of winging this. We want to go to the next one. Okay, so, oh, she's doing research on this. Oh, cool. Okay, so this is what is upcoming. So one of the things that she's looking at here is decay in cold climates. Now, I did my master's degree in Alberta, in Canada, and I can tell you that it's very, very, very cold there in winter. Like -40, warnings go out, uncovered flesh will freeze in less than 5 minutes. I moved there from sunny Vancouver, so that was a bit of a shock. So when we say May and June in Alberta, we are not talking 100-degree temperatures. Okay, I have known snow in there. Really, really warm there. So that's why I should be looking at the difference between cold climates and hot, arid climates, and also the effect of moisture. And this would be particularly not just ambient humidity, but groundwater. I don't know if any of you have had issues with, you know, water seeping into your basement when there hasn't been any rain for a while and these kinds of things. There is often underground water sources that we don't know about. So she'd be looking at all these different factors. What's our next slide? Where are we going with this? Oh, okay. So tons and tons of resources. So Zoe has obviously done a lot of research on this. I'm guessing she's going to be a budding forensic anthropologist. I don't know that I can answer questions because I don't know exactly what else she's doing, but it looks like this was on its way to being some very interesting research. You have thoughts, questions I may or may not be able to answer? Oh my Lord, what did that woman do to my presentation? All right, thank you very much, everybody.
Lisa, just one.
Yes.
Just a remark, and that is that the deserts in northern Chile and southern Peru, the Atacama, really are remarkable in how well they preserve things, in part because there's so little of the scavenger life there.
That is a good point, whereas in our, as I mentioned earlier, in our main sort of hotbed of human evolution, like in, the East African Rift Valley and the Serengeti, there are many, many predators. So yes, that's a good point on the interaction. Again, we talked earlier about intersectionality of, scavengers, temperature, water sources, humidity, all these different things that come together. Fascinating world. Hi, Tom.
Hi, Lisa.
So Tom mentioned natural mummification and dry pictures, but I've seen a mummified baby mammoth in St. Petersburg. How does it differ between, yeah, it's called in the tree. Does that differ when you have cold areas? Do you get those same stages of decay or not?
I would not think so, because if you're frozen from the get-go, you are not going to get the bacterial and microbial activity that causes decay in the first place. What you are going to have a problem with, again, thinking about, sticky environments, if you want to be a forensic anthropologist, once thawing starts, like after you've dug something like that up, there would have to be very, very rapid remediation, because otherwise, once the thawing starts, your decomposition is going to start rapidly.
Yeah.
As
One
you would
more-
know.
Sorry, go ahead. One more very interesting factor that wasn't mentioned is I also saw something on the bog burials and anaerobic alkaline environments do remarkable preservation. And you're not even worried about the body thawing or decaying after they take it out. It's just been essentially cured. All of the Northern European bog burials, they get bodies out that soft tissues actually preserve the bones decay. It's acidic, I'm sorry. It's a very unusual environment, but pH is not being mentioned here, and it's still another factor.
Hello, my name is Jared Sharfstein. I did a case study on Lake Apatcong, the largest lake in New Jersey, on the 2019 algal bloom that shut down the lake for the entire summer, caused a lot of health issues in native organisms and people who swam in the lake. Overall, just wasn't a good situation. So I'll start out talking about this specific case, and then I'll move into more algal blooms in general. So to start off, Lake Apatcong is the largest lake in the state of New Jersey. It is primarily in Apatcong, hence the name. It is there are many boaters, swimmers. There's a couple beaches on it. Very highly recreational area. There's Apatcong State Park is on the shores of that lake. Come 2019, we had a harmful algal bloom coming across the lake. If you look, I believe in the bottom left, all the green water, that's algae, which is toxic after a certain point to both humans and native organisms. Healthy water is obviously blue, maybe a little bit brown because it's lake water, but come these algal blooms, the water gets so green and viscous that it's also difficult to swim through. It's not just a visual effect. Causes of this particular algal bloom was the high rain and high temperature in the area at the time. Usually temperatures in the summer are around 84 in Jersey. This summer it was consistently above 90, reaching temperatures of 99 and into the hundreds, which are prime breeding grounds for canibacteria, which is the kind of bacteria that causes harmful algal blooms. Healthy amounts of canibacteria in lake water, because it can be good for the environment in moderate amounts, is less than 20,000 cells per milliliter. But at this time, it was upwards of 198,000 cells per milliliter. When it reaches that level of concentration, you get all kinds of issues. If you swim in it, you'll get rashes, skin infections. If you drink it, if you swim in it, you get water in your mouth. You can get gastrointestinal issues and stomach bugs. It won't be fatal to humans, but smaller animals like dogs who live on the sides and the shores, fish who live in the water, and anything else that goes that's smaller than human basically can and will die because of it. So the main causes of this harmful algal blooms can be a lot of things, honestly, but primarily in highly agricultural regions like Western New Jersey, it is fertilizer runoff that causes it, because the algae, it's a plant, it thrives on the same stuff that our crops thrive on, so that gets in the water, which then causes the algal bloom, which leads to the absolute destruction of the ecosystem. The other important thing to note is algal blooms can be reoccurring. Like once they happen one year, they typically die over the winter. But if they don't, they can come back stronger the next year if things aren't implemented to mitigate the problem. Mitigations can include anything from chemical treatments like FOLOC, which is a phosphorus-based chemical, which goes in and doesn't necessarily kill the algae, but it stops it from being able to reproduce, which is so it won't stop the algal bloom once it's in motion. Nothing really can. It'll stop it from reoccurring. There's a lot of things that go into algal blooms to begin with. It's not just fertilizer, it is also sewage can cause it. Any like I said, Backland is highly populated. A lot of people live on the shore, so if a pipe burst and a sewage pipe got into the lake, that could cause the algal bloom. Other causes can include just high temperatures, high rain. It's a natural occurrence that, like when most things happen when humans get involved, gets out of hand, and then we can't really fix it. I think that's pretty much all I have for this. So I have a sources slide next if you want to flip over. I went into all kinds of weather databases and algal bloom research in and of itself, but that's for the most part all I got.
Questions?
Okay, it's naturally there. It's just because of the high temperature, there is.
Yes, it is cyanobacteria. It is naturally found in most places, in all honesty. It is anywhere there's still water, it's just a regular kind of bacteria, but when certain thresholds are met, like temperature or nitrogen content in the water, it can explode in reproduction, and then the algae produces a toxin, which is what makes people sick.
Like for still water, like I've heard like still water, there's a lot of bacteria that it's really dangerous. Like
Yeah.
human eating bacteria as well.
Still water is a different problem than this. This is still water is dangerous because it is the perfect environment for new bacteria to evolve because there's no flow and no movement. It's basically just primordial soup. If you know what that is, it's just prime environment for new things to be created. A lake isn't anywhere something new can be made, but it's somewhere that pre-existing harmful things can reproduce and become toxic in the right quantities.
So I've seen that various smaller ponds and lakes have had aerators installed that churn the water and also probably move oxygen into the water. What effect does this have? Would that, obviously it's not going to help much once the bloom occurs, but does it prevent it? Does it have no effect? Do you have any idea?
For my research, aerating it won't have too much of an effect on the actual algae itself. What it will stop happening is it'll stop the water from being deoxygenated, which is one of the main killers of fish of organisms in the water, because the algae just actually there's enough of it, the water becomes deoxygenated, and everything in the lake will suffocate. The aerator stops the suffocation.
Thank you.
So you said it's not as fatal to human, but it is fatal to small animals like dogs.
Yeah, dogs will get very, very sick, potentially die from it. Because it is toxic. The only reason it's not toxic or fatal to humans is because we're large enough that we can fight it off. But in the same way that like salt can kill a snail. Salt won't kill us or kill us in the right quantities. It's just a matter of quantity, not quality.
Actually, used to go to Lake Alaca, but are they doing like, do they do treatments, like chemical treatments that help prevent it or anything?
I think immediately after they made some changes in legislation to stop fertilizer runoffs and stuff like that, I don't exactly know if they put in chemical treatments. I know they did when it was happening. They also had boats that swept across the surface of the lake and physically picked up the algae, but I'm not sure about current chemical treatments.
Is this a concern for saltwater too, or just freshwater?
I believe it's primarily a freshwater concern. There may be algae blooms that can happen in saltwater. I didn't research those. I'm not 100% sure. Yes.
On Cape Cod, it does.
Yeah.
Are there any natural deterrents or do we always have to go chemical?
The main natural deterrent is winter. So it'll happen over the summer. It'll happen when the climate's right, and then it'll die off when the lake freezes over. There is, however, a risk or concern of it coming back next year if there's still remnants. If the algal bloom was large enough that in the bottom of the lake it's still settling, and when it gets warm again, it reincarnates, if you will, it comes back.
All right, so during the summer, there's nothing that we.
Yeah, we can't, even during the summer, nothing we can do to get rid of it. Winter has to come and kill it all off. There is no foolproof way for humans to eliminate the algal bloom once it starts. Any other questions?
So there was a question on this topic before that you might be interested. Is introducing certain kind of fish that might eat the algae.
That's the first I've heard of it. I'll look into it though. It does sound interesting. Is that all?
Okay, so I just wanted to point out that the cyanobacteria is sometimes called blue-green algae, and this is very important in vibration because it does put a lot of oxygen into our atmosphere. This is
Thank you.
Good afternoon, Seton Hall. My name is Serge Alexander, and I'm joined with my two group mates. And we'll be presenting
What Waste?
Now you may be asking, why what waste? I also invite you to ask, what does Turks and Caicos Island struggle with the most? And we as an island struggle with land pollution, mainly coming from plastic. With an economy that thrives on tourism, having an island filled with plastics and plastic trash is not attractive, therefore not beneficial to our economy. So for our project, we plan on changing the methods of recycling into converting this plastic into bio-oil. We can make this process possible through pyrolysis, which is the chemical decomposition of those plastics by heat in the absence of oxygen. And this will be typically done under an environment which has 500 degrees Celsius or more, or in Fahrenheit 959 degrees Celsius or more. Through this, we should be able to chemically decompose this biofuel and this bioplastic into biofuel, which should in turn be used to light up an oil lamp or charge up a phone. Hypothesis. We hypothesize that through the process of pyrolysis, we should be able to light up an oil lamp or charge a phone.
Materials. For our project, we use 1 pressure cooker, 2 heat sinks, 1 propane stove, 1 thermal compound, 1 aluminum sheet, alligator clamps, and 1 thermoelectric power generator model.
Procedure. For the steps we took for our pyrolysis process, we first placed the plastic waste into the pressure cooker. Second, we unscrewed the pressure regulator from the lid of the pressure cooker. Thirdly, we insert one end of the pipe onto the stem of the pressure cooker where the pressure regulator once was. Afterwards, we use a hose clamp to secure the pipe onto the stem. After, we insert the other end of the PVC pipe into the plastic water bottle. And lastly, we tape the pipe and the water bottle together. Now, for the steps for our thermoelectric generator, we first attach the thermoelectric powered generator Peltier module to the bottom of the aluminum sheet and use a welding solution to glue them together. Secondly, we attach the heatsink to the thermoelectric power generator Peltier module using the same welding solution. Thirdly, we attach another heatsink to the top of the aluminum sheet Next, we create a base, and we do this by vertically attaching each of the 5x2 wood panels to one side of the aluminum sheet. After our base is created, we place the oil lamp with the bio oil underneath the generator. After placing it underneath the generator, we attach the wires of the thermoelectric power generator Peltier module to the alligator clips. After that is done, we attach these same alligator clips to a light bulb holder with wires. Light the oil lamp, and lastly, the indication of power should be shown through the light bulb being lit.
Data. For our project, we ran a total of 5 trials, 4 of which were the pyrolysis process, and 1 was to check if our generator actually worked. So, in our first trial, we used polyethylene film, and this type of plastic is commonly found in chip bags. So we put 5 pieces of it into the pressure cooker for 30 minutes and left it at a heat of 300 degrees Fahrenheit. After the 30 minutes was up, we checked again and we were left with a total of 2 pieces. Next, we left it for another hour and 30 minutes with a temperature of around 225 degrees Fahrenheit. Then we were left with 0 pieces, but no bio oil after this first trial. For our second trial, we used high-density polyethylene, and this type of plastic is commonly found in bleach bottles. We did a total of 8 pieces for 1 hour, and we did it around a heat of 600 degrees Fahrenheit. After the hour, we were left with around 4.5 pieces. Then we put it again for an hour and 30 minutes with the same temperature of 600 degrees Fahrenheit, and we were left with 0 grams of bio oil. For our third pyrolysis trial, we did regular polyethylene plastic. We did a total of 6 pieces and left it for an hour with a heat of 600 degrees Fahrenheit. We were left with 0 pieces and 0 grams of bio oil. In our last pyrolysis process, we did polyethylene terephthalate, and this type of plastic is commonly found in water bottles. We did 8 pieces and left it for an hour and 30 minutes with a heat of 600 degrees Fahrenheit. After the hour and 30 minutes, we were left with around 4 pieces and left it for another 3 hours with the same heat. Since all failed with these 4 trials, we decided just to see if our generator had worked. We substituted our bio oil with a candle, and the heat of the candle was around 300 degrees Fahrenheit and produced around 4.67 volts of electricity. Then we lit the candle a second time around a heat of 400 degrees Fahrenheit, and this produced 1.28 volts. We tried one last time with another candle, and the heat of that candle was 221 degrees Fahrenheit and produced 0.79 volts. We observed that we weren't able to gather any bio oil, even using a variety of plastics. We also realized that the burning plastic had left us with a foul scent, similar to that of bleach. Lastly, we also realized that there was a brown residue that would be left behind every time we would pyrolyze the plastics. In addition, the plastic eventually turned into this brown watery substance and eventually hardened after cooling. Variables. Our project, we have 2 sets of projects, basically. One, our first independent variable will be the amount of plastics that it was wasted throughout the process of pyrolysis. And as it was mentioned before, the process of pyrolysis is basically putting plastic to heat in a closed space where oxygen cannot come in or nor come out. Then we have the dependent variable, which will be the heat. Then we have the other part of the project where the second independent variable will be the concentration in the amount of heat produced during the procedures. And then lastly, the dependent variable for the second part of the project is the amount of electricity that we gain from this amount of heat that we gave the project. Analysis. Well, our results suggested that while polyethylene can be fully decomposed, for ours, in our case, it was not fully able because of the conditions that we were working. One of the main factors was the amount of heat that we gave the project. It was not at its full potential for the plastics to fully decompose. Further investigation is needed to optimize our project throughout the process of pyrolysis, and we need to explore other factors that will help this project. Conclusion. In conclusion, our project was not successful, but throughout the process of paralysis, we saw that there were certain things that we could have done better, such as kind of heat that we gave the project. We had three trials that were conducted to assess the temperature of the makeshift flames and the corresponding electrical output. It didn't work. However, the overall voltage level achieved something. We were able to at least gain something from the project. Not what we wanted, but at least it was something at the end. But it was the amount of electricity that we gained was still below the amount of electricity that it needs for any practical applications.
Thank you so much, Stephen Hall, for taking the time out of your day to listen to our project. And remember,
What's from waste? No time to waste.
Hello, everyone. For those of you who don't know me, my name is Elaine Davis. I am in the Museum Professions Master's Program, graduating next month. And I will be talking today about my thesis project, which was a professional development guide on learning disabilities in museum education. If we could advance to the next slide. So I'm just going to be discussing my project step by step, including the chapters of the thesis, some of the key findings, and then the artifact that the project produced, the neurodiversemuseum.com. Next slide. So I have been an educator in museums and middle school, and I have noticed how receptive people with neurodevelopmental disabilities are to the museum education environment. So these environments are very social. They're less rigid than traditional classrooms. They're often more interactive with visual, tactile, multisensory elements. And then educators are often able to specialize more than classroom educators can. However, according to Kahn and Zankowicz in 2022, while museums are currently focused on DEAI, the accessibility isn't always given the same focus. And Boughton 2023 kind of built on this by adding that invisible disabilities like learning disabilities are much easier to overlook than visible disabilities such as impaired mobility. So for the purposes of this project, I'm looking at traditional learning disabilities as well as autism after Beth Redmond Jones in 2022 and dementia after Yang He in 2021. They did some interesting studies that found the accommodations across these neurodivergences are very similar. So I've kind of taken a very wide view of what we could consider a learning disability. Next slide. So in 2020, Wilkening Consulting did a study that found over half of museum-going families, 53%, have some sort of disability-related access needs. And then last year, Attitude Magazine surveyed their readers and found that 54% did not feel museums were well equipped to accommodate neurodivergent visitors. So in both of these surveys, these are large portions of the sample that show quite a large unmet need. So I kind of asked, what can I do about this? Next slide, please. And I chose to address this by creating a professional development guide for museum educators because I found that none really existed yet. There were a few academic studies that had some fairly strong findings sections, but if you are working in the museum field, you may not have access to those academic journals, and you may not have the time to be going through all these different academic journals and reading all these journal articles to kind of gather the best practices. So it needed to be something that was practical for museum professionals working in the field. Next slide, please. All right, so my research question then was, how can museums adapt the existing research on museum education and learning disabilities to better facilitate lifelong learning for people with learning disabilities? My literature for this section was very interdisciplinary because while I did find a few academic studies related to the disabilities I wanted to address, there were not a ton. And a lot of the foundational museum studies literature did not include disability. So I looked to critical disability theory and related literature of that variety in order to fill in those gaps. Next slide, please. So I originally intended to kind of focus group this. I wanted to interview people who were working in museum education currently, people who were working in special education, elder care professionals, people who kind of had the experience in the field and could give me the best practices they'd garnered from their experience. But then as I was doing my literature review, I actually found a workable amount of sources to at least start the project off. And, excuse me, the timing was a little bit better as I was doing this as my master's thesis. And, you know, just the availability of sensitive information. Disabled people are a protected class of people under the Institutional Review Board, and I wanted to be very sensitive to that. So I kind of took this approach where instead I used qualitative comparative analysis and textual analysis of those academic sources I had found for my lit review and professional development guides for special education, and gathered the best practices from there. And I'll talk a little bit more about that in a sec. And like I said before, I wanted to do this as a creative project because people working in the museum field are not often academics. And as Kroll 2009 pointed out, sometimes the best showcase of a person's knowledge is not an academic thesis because their audience is not fellow academics. My audience is working professionals, so I wanted something that was accessible to them. Next slide, please. So my findings, I had this data pool of 10 sources, found 6 that were academic. There just weren't a lot more than that, and 4 that were pedagogical. And after those 4, there started to be diminishing returns vis-a-vis new information. So I used those 10 and found 11 themes with strong support. By strong support, I mean that multiple sources, more or less said the same thing. So out of those, I found 11 major themes, and then within the individual pieces of literature, there were the occasional outliers that had strong support within their own text, but weren't necessarily backed up by any of the other sources. So those were worth including because they were relevant to the project at hand. And then specific findings were compiled into these bullet points that were sort of categorized by where in the process of planning and delivering museum programs they take place. Next slide, please. Yes, so this is actually what the guide looks like on the webpage, and they're divided by best practices for creating new programs, for running programs, and then additional practices for specific types of museums. Because if you are, let's say, running a history program, then the best practices for like physics related lessons are not going to be super helpful. And a lot of programs are, they have already been running for a while. So the best practices for creating new programs are not going to be super applicable to the best practices for running programs. And this guide, just the arrows, those pop out so that a professional looking at the website can find exactly what they need in order to, I guess, best serve the type of program they're working on. So next slide. All right, so the website is live now. This is the artifact of my project, the neurodiversemuseum.com. It was actually built using WordPress through a hosting platform called Hostinger. And it is completely open access. I wanted to remove as many barriers as possible. A lot of museums, they don't have the extra funding or the extra time to be, I guess, paying for additional training programs. So this is completely open access to the public. Anybody can search up this URL and have like full access to the guide as it is now. Next slide, please. And while I didn't do focus groups, I did always want this to be a living project. So there are channels through which people can get in touch and add their own feedback that can be incorporated into future versions of the guide that will be updated right on that page that we saw previously. Because I don't believe that the guide as it is now is the definitive version. The museum world is always changing, education is always changing, society is always changing. So, the guide as it is now is perfectly workable, but it is not the be-all, end-all of accommodation. And I want it to be, I guess, able to be updated as needed and able to be something that everybody can kind of contribute their experiences to. So next slide, please. So museums, they are community organizations and they're educational institutions. They're always changing, and by making efforts to include marginalized communities, these communities grow stronger, seeing improvements in education and participation in society. Museums also grow stronger, increasing their audiences, which increases their knowledge, which increases their trustworthiness, which increases their funding, on and on in a circle. Last slide, please. Thank you all for taking the time today to watch this presentation. I have my contact info there if you have any questions later, and I'm willing to take questions now as well.
You can hear you?
Thank you, Dr. Delosier.
Hello.
And Dr. Kimball.
So with such a strong foundation of the website you made, do you have any plans on making any more improvements for future of the website?
For sure. Like I said, any feedback that is given to me will be taken into account, and I do plan to update this. And I'm also considering ways I can sort of expand it. So it's not just neurodiversemuseumeducation.com, it's the neurodiversemuseum.com. So I do want to start thinking about in the future ways to support fellow museum professionals, ways to support, you know, neurodivergent people in other areas of the museum as well.
Thank you.
Great question. Thank you.
One more question.
Can you hear me?
Yes.
Okay, so I know your project was mostly focused on museums, but
Mhm.
could this also be implemented into like zoos and aquariums?
Into what?
Into zoos and aquariums, like other kind of
Oh,
similar
yeah.
fields?
Absolutely. Actually, I am pretty sure one of the studies that I looked at was one from a zoo. So, yes, zoos and aquariums, they're part of this museum field because they have collections that are maintained for public education. They're very similar types of educational institutions. So yes, this guide is absolutely applicable to zoos and aquariums. And I think that while there isn't a specific section of the guide for that, I think that the influence of that source that was zoo/aquarium is definitely there. Like one of my examples that I gave is just, clearly communicate ahead of time what to sort of expect. Like if you can't provide an indoor environment, let people know that the program is going to be taking place outdoors. Like that's part of it. Just understanding what environment you're going to be walking into is helpful for neurodiverse people. And there are other pieces of advice that are broadly applicable as well. So thank you.
Thank you.
Mhm.
Yeah, go ahead.
He's gonna ask a question right now.
Can you hear me?
Yes.
Okay, so my question is, I see on your website that you have additional practices for science programs, history programs, and art programs. Do you plan to add more different types of programs based on other fields of study like math, language arts, religion, etc.?
So this is very focused on museum education. Like under the science section, it does say STEAM for all. So it is sort of that science and math focus. Museums I've found don't do as much with literature, and religion maybe. But the focus is mostly what you'll come across in museum education. And, that's interesting. I haven't actually looked into too much, at least, into the ways that museums can do religious education. I know Newark Museum of Art has, I think, a Buddhist temple. Yeah, a Buddhist temple within one of their galleries. So that would definitely be an interesting thing to look into. But it's not something that I have looked into yet.
Thank you.
Yeah.
Hello, I live in Maplewood, and we have a zoo. I don't know if you guys know that, but we do. And we have been working on it for a number of years. It's getting pretty good. Anybody who hasn't been there really should go. It's very nice. And lots of big animals too, not just little, no. But anyway, I think if you have that, I think it might be a good thing to have a zoo. I really do. And so anybody who hasn't been there, please do.
Do you want to tell them?
You have a question.
I have a question.
So it is the Turtleback Zoo, and I believe it's in West Orange.
Yeah. I just, that's all.
I have one more question. Could you give us some, it's about knowing before you go.
Sorry, what was that?
You already told us that the family person should be prepared to know what environment. Say quiet hours or something. Light or smells or whatever. Enjoy the experience at the museum.
Okay, there's a lot of background noise happening, but I think I got the gist of what you're saying. But yes, one of the things that educators can do is just like when they're sending out an itinerary, kind of give an overview of what to expect environmentally. Yeah, I do think that that's important because there are those sensory inputs that can be distracting or otherwise, not great, such as like, we're going to be outside, it's a sunny day, be prepared for that. Or, we've got some sections, we're going to be taking a walking tour of the zoo, and, some sections are going to be louder than others. Some sections might have stronger smells, and just, I guess, preparing people for what to expect goes a long way. I hope that answered your question. There was a lot of interference while you were trying to talk, and I'm not sure if I heard you right.
I think you did a great job here. I also just wanted to thank you for presenting early. We were a little ahead of schedule and you weren't here, so you weren't aware of that. We were like, hey, go ahead. So we really appreciate your flexibility here. Thank you.